this video, inshallah, I will conduct chi-square goodness of fit for binomial distribution. The null hypothesis for this question said the distribution is a binomial with n equal 3 and b equal to 5. And the alternative said no, it is not a binomial distribution with n equal 3 and p equal 0.5. We will use the alpha, which is the significant level, as 0.05. The first step, I have to find the probability, so I will write equal binomial distribution. The first part, or the first entry here, is the number that I would like to find the binomial distribution for it, so it is 0 here, and then comma the number of trials, so it is 3, and then the probability, which is p here, 0.5. And the last part, they asking me, is it cumulative? So do you want it to have less than or equal 0 or cumulative, or just, I mean, the 0 itself? That means, is it equal to 0? Just I need to have the 0, so I will write 0, or you can write false. So false, just give me 0. Don't give me less than or equal 0. So just give me 0. So here I will write false, or you can write 0, close it. Now I need to have the probability for 1, so I will do in Excel, do it for me. Then I need to find the expected equal. The expected is equal to, first of all, I need to find the total, which is tested, so because the total of the observed need to be the same as the total of the expected, and the total of the probability must be 1. So the expected here, I need to say equal, and then I multiply each probability by the total. So multiply by the total, and here is the expected, and then we can see here the expected is 200 and the observed is 200 and the probability is 1. So we are doing a very good job. So now I need to find the chi-square test statistic. So it is the O, which is the observed, minus the E, which is the expected, squared divided by expected. So I will write equal the observed minus the expected squared divided by expected itself. So we have the chi-square test statistic here, which is equal to 2.4. Now I need to find the chi-square. I need to find the chi-square critical value, or chi-square alpha. So I will write chi-square inverse RT, right tail. And then they ask me the probability, they mean the alpha, comma, and the degree of freedom. So we come here, we have 4 of them. So 4 minus 1 equal 3. And then we have the critical value here. Also, we can find the b-value. To find the b-value, we can say equal chi-square test actual range, which is they need the observed, comma, expected range, they need the expected, close it, and here we go, this is the b-value. So to conduct the hypothesis for this case, we have 2 ways. Either we use the b-value, we said the decision rule, if b-value less than alpha, we reject the null hypothesis. If chi-square test larger than chi-square critical value, which is chi-square alpha, reject null hypothesis. Oops. Excel don't accept this. Okay. Then reject the null hypothesis. Otherwise, don't. So here we can see that the p-value is larger than alpha, which is equal 0.05. So if p-value larger than alpha, we don't reject the null hypothesis. Also, we can see that the chi-square test less than chi-square critical value. We say that if chi-square test larger than chi-square critical value, so we reject the null hypothesis. But the chi-square here is, otherwise we don't. So chi-square here is less than chi-square critical value. So we don't reject the null hypothesis. So p-value less than, larger than alpha, don't reject the null hypothesis. Critical chi-square test less than chi-square critical, so we don't reject the null hypothesis. So the conclusion, do not reject null hypothesis. We conclude that the distribution is binomial with n equal 3 and b equal 0.5. Or you can say it like this, do not reject the null hypothesis. There is sufficient evidence that the distribution is binomial with n equal 3 and b equal 0.5. Or you can say do not reject null hypothesis. There is no sufficient evidence that the distribution is not binomial. So you can say we don't reject the null hypothesis. So we said what the null hypothesis said for our case is acceptable. So the distribution is the binomial. This is the first way of the conclusion. Or we can say yes, we don't reject the null hypothesis. So in this case, we agree with what the null hypothesis said. So the distribution is binomial with n equal 3 and b equal 5.5, and we have evidence for this. Or we can say we don't reject the null hypothesis, and we back to the alternative. We said there is no sufficient evidence about what you are saying. So there is no sufficient evidence. The distribution is not binomial. So we conclude that the distribution is binomial. We say there is sufficient evidence that the distribution is binomial, or we say there is no sufficient evidence for you, the alternative.